So in the last lecture, we talked about some basic statements. We talked about some basic compound statements. In this lecture, there are a few English phrases that it may not be immediately obvious how you should translate them. So we're going to take a look at those, and then think a little bit about how we can translate more mathematical statements like inequalities into a logical version. So the first statement I want to talk about is this English word but. Right? How would we translate two phrases, two statements? Right? I've got two statements here. I am going is the first one, and I will be home is the second one. How would I translate two statements combined with this word but into our logical form? And I've got the answer here, right? This but is equivalent to and, so I use the logical and symbol here. But I want you to think about why. Right? Let's say I said this to you. Let's say I'm going, but I will be home. Right? What is your expectation? Right? Your expectation is first that I'm about to leave, and keyword there, right? And that eventually I will be back. You expect that I will do the first thing and the second thing. Right? That's why this is equivalent to an and statement. All right. So how about this? This is our second one. How about neither this nor that, right? So again, I've got an example here, right? I am neither going nor will I be home. So going, that's going to be the P, and I will be home. That's the Q. And I've told you how to do this here. This is not P and not Q. But again, let's think this through. What is your expectation? Right? If I say I am neither going nor will I be home, you expect that first I'm not going to go, right? So that's the not P. And you expect that I will not be home, right? So that's the not Q. Right? So this is how we would translate neither something nor something else into a logical statement. All right, so how about inequalities, right? What does x less than or equal to a mean? Well, we kind of have two possibilities here, right? One possibility is that x is less than a, and the second possibility is x equals a. And I want you to stop and think for a minute. How should I connect these? Well, hopefully, if you think about it for just a minute, it can't be and. It can't be and because there's no way for both of those things to ever be true. And we know that if you pick an A, there will be numbers less than that, right? So this is going to be an or again, if I write this with my logical symbols, it would look like this. All right, so how do we do a compound inequality like this one? Well, again, think about what this is saying about x. What has to be true of a number for it to be between a and b? Well, first, the number has to be greater than a, and the number has to be less than b. So this is how I would read a compound inequality. Again, we can use our new symbols here, x greater than a and x less than b. Right, so finally I've got kind of a mixed one here, right? Less than and less than or equal to. So how would I write this? Well, I'm going to follow the same pattern. I would say x greater than a, and I'm just going to start going right to the math symbols now. X less than or equal to b. And now I could take this a step further, right? Because I've got my kind of my explanation of less than or equal to over here. I could make this x greater than a and x less than b, or x equals b. Right? That's how I would translate kind of a mixed compound inequality. All right, so where are we going next? Right now that we have this idea of how to take an English statement and turn it into a math statement, if you will, our next step is going to be to think about how we can evaluate the validity of a compound statement. Under what circumstances is a compound statement true or is a compound statement false? We're going to do that with something called a truth table.